For this example, I have an equation sort. So you're going to be sorting these equations into 4 different columns, and they're all absolute value equations, and we're relating it to the parent function, which is a V shape going up. So all of these equations, we're going to be sorting them according to the number in the very front, called your A value. There's usually a variable here called A. And the first column, this first column would be graphs that are more narrow in comparison to the parent function. You might also hear the word horizontal compression, which means horizontally, you think of it like pushing it in. Or you might hear the word vertical stretch. Think of like taking a rubber band and stretching it up. It would get narrow. Some of these will be wide in comparison. So a horizontal stretch, you're stretching it left and right here, so it's getting wider. Or you might hear the word vertical compression, which means you're pressing it down, so it would get wider. The third column is for those that are narrow and they also got reflected. And then the final column is wide and reflected. So I'm going to search first for the narrow equations, and all of these narrow equations need to be going up. So how do I know if they're going up, and how do I know that they're going to be narrow? If they are going up, the value in the very front better be positive, and the narrow equations have an A value that's bigger than 1. So for instance, this is bigger than 1. This value is larger than 1. 4 is bigger than 1. And in fact, 5/2, which is 2.5, that's also larger than 1. And if you remember, the number in the very front represents your slope when you graph it. So for instance, this first one, your slope would be 3/1. So once you plot the vertex, you would go up 3/1, up 3/1, and so forth. So those 4, I'm going to sort them in this first column called more narrow. So that takes care of this one. Here's this one. F of x equals 4 absolute value x minus 1 plus 3. And then the final one, f of x equals 5/2 absolute value of x. All right, the next column will be those that are wide in comparison, and they have to be going up. So again, I'm looking for only positive A values, and then if it's wide, the value in the very front will be between 0 and 1. So I see 2 functions. 2/3 is between 0 and 1, and so is 7/10. So both of these would be wide in comparison because the A value in the very front is between 0 and 1. All right, moving on to the next column. So for this next column, I'm looking for narrow and also reflected. So remember narrow, back to this very first column. If they're narrow, the number in the very front, ignoring the sign, is bigger than 1. But in order to get reflected, meaning it's going down, there has to be a negative there. So taking a look at the remaining examples here, all 3 of them are negative, which is why they belong under the reflected columns. But we're looking for values ignoring the negative that's bigger than 1. 1/5 is not bigger than 1. Neither is 1/10, but I see 5. Ignoring the sign, 5 is bigger than 1. So the 5 makes it narrow, and the negative reflects it. So f of x equals -5 absolute value of x. So again, the 5 makes it narrow, the negative reflects it. And then finally, my last column here, wide and reflected. So just like the previous, the negative reflects it, but the number in the front, ignoring the sign, the 1/5 and the 1/10, because that's between 0 and 1, that makes it wide. So these last 2 here belong under wide and reflected.